The most damaging part of Starfish Prime was not the flash. It was what happened after the flash disappeared. On July 9, 1962, the United States detonated a 1.4 megaton nuclear device roughly 400 kilometers above the Pacific. There was almost no atmosphere around it, no city beneath it, no ordinary mushroom cloud, but the explosion changed the space around Earth. NASA later summarized the aftermath this way: 7 satellites were lost within months, primarily because their solar cells were damaged by radiation. Telstar, launched the next day, absorbed an estimated dose 100 times greater than expected, and later failed. Starfish Prime did not simply explode in space. For some spacecraft, it kept exploding long after the light was gone. 3 effects arrived together: a nuclear flash across the Pacific, an electromagnetic pulse, and a new artificial radiation belt around Earth. Starfish Prime belonged to Operation Fishbowl, the high-altitude branch of the much larger Operation Dominic Test Series. The launch site was Johnston Island, a narrow strip of coral in the central Pacific, roughly 1,400 kilometers southwest of Hawaii. At 11 p.m. local time on July 8th, July 9th, an Ucha-Thor missile rose from the island carrying the nuclear device and 3 instrument pods. The Thor climbed toward space. Then, at approximately 400 kilometers, the device detonated. That altitude is near the orbital height of the International Space Station. The weapon was detonated inside the near-Earth environment used by spacecraft. Its 1.4 megaton yield was about 93 times the explosive yield of the Hiroshima bomb. In near vacuum, its radiation and charged debris interacted with the thin upper atmosphere and Earth's magnetic field. The sky itself became part of the experiment. The word prime was there because the first Starfish attempt had failed. On June 19, 1962, another Thor left Johnston Island carrying a nuclear warhead. It flew normally for about 59 seconds. Then its rocket motor stopped. Range safety ordered the missile and warhead destroyed between roughly 9 and 11 kilometers. Above the island, pieces fell on Johnston and into the surrounding lagoon. Recovery teams spent 2 weeks collecting debris, some of it contaminated with plutonium. Less than 3 weeks later, the United States tried again. The successful shot was Starfish Prime. Fishbowl suffered other dangerous failures. Later that month, a bluegill missile malfunctioned on the launch pad. Its warhead was destroyed before any nuclear yield, but the accident spread severe alpha contamination. The glowing archival images hide a program that repeatedly came close to disaster on a tiny island. When Starfish Prime detonated, observers across the Pacific saw a sky that should not have existed. Official histories describe artificial auroras on both sides of the equator. Some displays lasted as long as 15 minutes. Observers on Kwajalein, thousands of kilometers from the burst, reported the spectacular glow lasting at least 7 minutes. At Johnston Island, the major visible effects faded within minutes, leaving a faint red glow. This was not an ordinary polar aurora driven by a solar storm. Charged particles from the explosion followed Earth's magnetic field. Some traveled toward the magnetic conjugate region in the opposite hemisphere, depositing energy into the upper atmosphere and making it glow. That is why the colors appeared far from the detonation point, and why the geometry of Earth's magnetic field mattered as much as ordinary distance. For people watching from Hawaii, the event was a brilliant light show on the horizon. For electrical systems and satellites, the invisible effects mattered more. A high-altitude nuclear electromagnetic pulse is not one single wave. Engineers divide it into components. E1 rises in billionths of a second. E2 lasts longer. E3 develops over seconds to hundreds of seconds and can interact with long conductors like an intense geomagnetic disturbance. The fastest part begins with prompt gamma radiation from the weapon. In the upper atmosphere, those gamma rays knock electrons out of molecules. These Compton electrons are deflected by Earth's magnetic field, creating a rapidly changing current. That current radiates an electromagnetic pulse toward the ground. Because the source region is high above Earth, it can have line of sight to an enormous area, but this does not mean every electronic object below is automatically destroyed. Cables are crucial. Long power lines, data lines, and antennas can collect energy and carry it into connected equipment. Small, isolated devices are often less exposed than the infrastructure supporting them. The mechanism is real. The claim that every radio, car, and pocket device must be instantly fried is not. Vulnerability depends on coupling, cable length, shielding, and system design. Starfish cannot predict a modern grid, 1-to-1, and the pulse was still not the longest-lived effect. The nuclear reaction produced enormous numbers of energetic electrons. Some escaped or entered the atmosphere. Others became trapped by Earth's magnetic field, bouncing between hemispheres and drifting around the planets. Natural radiation belts already surrounded Earth. Starfish did not create the Van Allen belts. It injected an artificial population and raised electron intensity in parts of the inner zone by several orders of magnitude. Charged particles spiral along magnetic field lines, reflect where the field strengthens, and slowly move around Earth. The result turned a fraction of a second detonation into prolonged orbital radiation. NASA studies found that the decay rate depended on particle energy and magnetic location. In some regions, the artificial population fell away over weeks or months. At low magnetic shell values, parts of it persisted for years. So there was no single expiration date for the Starfish belt. A satellite did not need to be struck by debris. Each orbit could add another dose. Solar cells degraded. Electronics accumulated damage. The bomb had created manufactured space weather. 4 days after the test, the British satellite Ariel could no longer generate enough electricity to function properly. Other spacecraft solar arrays began losing power. Telstar launched 1 day after Starfish into an orbital environment that had just been radically altered. NASA estimated that it received a total radiation dose about 100 times greater than expected, and it later failed. The wording matters. Starfish did not blast 7 satellites out of the sky at detonation. The belt increased their dose. Failures accumulated over days and months, mainly through solar cell damage and degraded electronics. NASA's later summary gives 7 losses within months. A single test had damaged a meaningful part of humanity's young space infrastructure. It is tempting to take Starfish Prime and scale it directly into a modern apocalypse. That would be bad science. Today, thousands of active satellites occupy different orbits with very different shielding and redundancy. They also depend on ground stations, power, and timing networks. A modern detonation could threaten them through prompt radiation, electromagnetic effects, and trapped particles. Severity would depend on weapon design, altitude, latitude, orbital geometry, and shielding. Grid effects would depend on conductors, transformers, grounding, protection, and recovery capacity. Starfish is not a perfect model of a modern attack. It is experimental proof that one detonation can couple into systems across radically different scales, from microsecond electronics to particle populations lasting years. You can replace a component. You cannot quickly sweep a radiation belt out of space. The United States continued the fishbowl series with lower-yield high-altitude tests. The Soviet Union carried out its own high-altitude detonations in 1962, also altering the near-Earth radiation environment. But the era was closing. On August 5, 1963, the United States, the Soviet Union, and the United Kingdom signed the Limited Test Ban Treaty in Moscow. It prohibited nuclear explosions in the atmosphere, underwater, and beyond the atmosphere, including outer space. It did not end underground nuclear testing, but it closed the arena Starfish Prime had opened. The footage survives as a glowing sphere and a colored sky. The real legacy is invisible, a pulse that crossed an ocean, electrons that circled Earth, satellites that failed months later, and a warning written into the space around the planet before the space age had properly begun. The flash lasted seconds. The experiment did not.